There are 4 steps when solving a series circuit. The first thing you always want to do is find that equivalent resistance, which is the total resistance of the circuit itself. So this is if we were to replace all the resistors or light bulbs with 1, this would be the amount of resistance we'd have to replace it with. Second step is to find the current supplied by the battery, and we'll find that using Ohm's law, V equals I times R. The third step in a series circuit is that all of the currents are the same. And the last step is that we find the voltage drops across each resistor, again using Ohm's law. So let's look at a circuit. Here we have a series circuit, just one path, one loop, and we need to find the equivalent resistance, the current and voltage drops across each resistor and the battery for this circuit. So the first step is to solve for the equivalent resistance. And to get the equivalent resistance, we simply add up the resistances of each resistor. So the equivalent resistance, I'll write my scratch work over here, is going to be 2 ohms plus 4 ohms. And so my equivalent resistance is 6 ohms. The second step is to solve for the currents supplied by the battery. And so as long as we have 2 out of 3 numbers, 2 out of 3 values, we solve for the third using Ohm's law. So V, voltage, equals I, current, times R, resistance. So blank times 6 equals 6. I can see that it is 1 ampere. That will be my current. So again, V equals I times R. We have 6 volts equals my current times 6 ohms. And so I solve and get that my current is 1 ampere. Now in a series circuit, all the currents are the same. So the current supplied by the battery is equal to the current through the first resistor, and it's also equal to the current through the second resistor. They're all 1 ampere. Now my final step is to solve for the voltage drop across each resistor. And I'll do that using Ohm's law again. So again, V equals I times R. And so for my first resistor, we have that V equals I, which is 1 ampere, times R, which is 2 ohms. And so my voltage drop across the first resistor is 2 volts. Then for my second resistor, again, V equals I times R, so my V for my second resistor is equal to I, which is 1 ampere, times R, which is 4 ohms. I get that the voltage drop across the second resistor is also 4 volts. So it's the same as, just happens to be the same as the resistance because I'm multiplying by 1. Now, a way to check my work for a series circuit is to add up the voltage drops across each resistor. And if I take 2 plus 4, I get 6. If that matches the voltage of the battery, then you know that you've probably done the problem correctly. So in this case, it does add up to the voltage of the battery, so we should be pretty confident that we've done the problem correctly.